Hello guys, welcome to Green Academy. Let's discuss another problem. The question is, a line AB measuring 70 mm has its end A 15 mm in front of VP and 20 mm above HP, and other end B is 60 mm in front of VP and 50 mm above HP. Draw the projection of the line and find the inclination of the line with both the reference planes of the projections. This is our question. Let's find out in which quadrant this line is lying. Okay, a line got 2 points, 2 endpoints. Here the name of the line is AB. What is the length of the line? It's 70 mm. Has its end A. One of its end A is 15 mm in front of VP. It's in front of VP and 20 mm above HP. In front of VP and 20 mm above HP. One of the point is lying in the first quadrant and other end B is 60 mm in front of VP. 60 mm in front of VP in front and 50 mm above HP and above HP in front of VP and above HP. That means the other end B is also in first quadrant. We can say the line is lying in first quadrant. Okay, and we have to draw the projection of the line and find the inclination of the line with both the reference plane. We have to draw the projection of the line and also we have to find the angle at which the line makes with both the reference plane. This is our line AB. The name of the line is AB. It's lying on first quadrant. This is our first quadrant. This is VP and this is HP. HP means horizontal plane. VP means vertical plane. Okay, and the point A, which is 15 mm in front of VP. This length is 15 mm and 20 mm above HP. A is 20 mm above HP. This is 20 mm. Okay, and the other end B is 60 mm in front of VP. 60 mm in front of VP. This distance is 60 mm and 50 mm above HP. This is 50 mm above HP. Here to here the distance is 50. From here to here the distance is 60. So this is our three-dimensional view of our question. Okay, what is the length of the line? Length of the line is 70 mm. So front view, from when we are looking from this side, we will get a front view. What will be the front view? It will be a straight line. Okay, and from when we are looking from this side, top side, we will get a top view in the horizontal plane. Okay, this is our top view in the horizontal plane. And my question is, what is the length of this line? Okay, this is 70 mm and is the line is parallel to VP? No, the line is not parallel to VP. So see here, the distance of A from VP is, what about this distance? This distance is 15 mm. If it's parallel to VP, this distance, this must be 15 or this must be 60. That means both the endpoints, the distance from the VP must be same. This is 60, this is 15. That means the line is inclined to VP, right? So the line is inclined to VP. What about here? The length of the A, the distance of the A from HP is 20 mm and the distance of the B from the HP is 50 mm. That means the line is not parallel to HP. It makes an angle. Here it's make an angle, right? Here all angle with HP and here it makes an angle with VP, right? So the line is inclined to both the planes. It's inclined to VP and as well as it is inclined to HP. Because if it's parallel to VP, the distance of the A and distance of B from VP must be same, right? If it's parallel to HP, the length of the distance of the A from HP, that is, this distance must be equal to this distance. So here this is our front view and this is our top view. We know the length of the line. So what about this length of the front view? Can you find out the length of the front view? Do you know the length of the front view? No, we don't know. It's not given. What about the top view? Is it given? No, the length of the top view is not given. So we have to first find out the length of front view and top view. Here the line is making an angle with both the HP and VP. So in the front view, when we are looking from this side, you will get an image on the VP, that is called front view. What about the distance of the front view? This is A dash B dash. What about this distance? Is it similar to, is it equal to 70 mm true length? No, it is not equal to 70 mm. Why is that? Because the line is not parallel to VP. If the line is parallel to VP, then only you get the true length in that projection, right? If the line is parallel to VP, you will get a true length in the front view. Here line is making an angle with VP, so the front view will be in reduced length. So we don't know the length of the front view. Then what about this top view? If the line, this line AB is parallel to HP, this is our HP. If the line is parallel to HP, then you will get true length in the top view. That is, the image, the shadow will be in true length. But here the line makes an angle with horizontal plane. So here you will get a image, or you will get a projection whose length is less than the true length. So the 70 mm is our true length. This length will be reduced length. We don't know the length, but it will be less than 70 mm. This is our top view AB. This is our XY. Suppose we will get a front view like this and top view like this. We have to rotate our horizontal plane. After rotating horizontal plane, we will get an image like this. X, Y, this is our vertical plane, and this is our horizontal plane. This is our vertical plane and this is our horizontal plane. Suppose we will get a line like, we will get a projection like this. This is A dash, B dash, this is AB, right? After the rotation of the horizontal plane. Here after the rotation of the horizontal plane, like here, look at this. Here after the rotation of the horizontal plane, we will get A dash, B dash, AB. This is our front view, this is our top view. A dash, B dash, front view, AB, top view. Image. So let's try to draw this image, right? This is our XY line, okay? This is our XY line. Can you spot the point A dash, A dash, A dash? This is how much distance from the XY line? This is 20 mm. Then this will be 20, right? We can spot 20. Taking 20, this is our A dash. And what about A? How much distance below the XY line? From here to here, how much distance? That is 15 mm in front of VP. So here it's also 15 mm. So this is 15 mm. We can spot A. Then what about this length? We need to find out this length. What is this length? Is it 70 mm? Is this length is 70 mm? No, it's not 70 mm. It's less than 70 mm. Can you find out the distance? Can you know the distance? No, we don't have the distance. Okay. Do you have this ankle? Do you know how much? What is the ankle? This ankle? No, we don't know the ankle. What about this distance AB? This is our distance AB. Do you have the measurement? No, we only have the true length of the line. This is the reduced length. This is reduced length and this will be reduced length. We don't know the reduced length. Okay, so we don't know how to draw the projections. We don't know the reduced length of the front view nor the top view. We don't know the inclination, at what angle the line is making with HP or VP. We don't know. So how to draw the projections? In order to draw the projections in this type of question, where the line is inclined at both the plane, both HP and VP, we follow one method that is called rotating line method. This is called rotating line method. So what is rotating line method? Here the line is inclined at both the HP and VP. So in both views, neither of the front view or top view gives true length. Both the length are reduced length and we don't know the reduced length. Okay, so we have to find out the reduced length first. So the method is very simple. We have to rotate the line and make the line parallel to one of the plane. Okay, keeping one point constant, we have to rotate the line and make the line parallel to one plane. So here I am keeping the point A. So here this is our quest line. I am keeping the point A constant and I am going to rotate the line and make the line parallel to VP. Okay, without changing the distance from the HP, or without changing this angle. Okay, without changing this angle, I am rotating the line. So how to rotate the line? So here, look here, I am keeping the point. This is my point. This is my point A, that is 20 mm above HP and 15 mm in front of VP. Okay, I am not changing that point. Okay, but I am changing this point. I am making this point. This is the distance from vertical plane is here. This is 60 mm, right? I am reducing that distance. I am making the distance here 15 mm. So here both the plane, this is B, this is VP. The distance from VP, that is VP to B and VP to A, that is 15 mm. That means the line is parallel to VP. And what about this length? I am keeping the length same. This is 20 mm, this is 50 mm, right? This is 50 mm. I am keeping the distance same. That means I am not changing this angle. I am not changing this angle. This angle I am not changing this angle. I am keeping the angle same. How to keep this angle same? I am not changing the distance from HP. I am only changing the distance of the B from VP. I am keeping the distance same. Okay, so here I make this line, I rotate this line parallel to VP by keeping the angle same, by keeping angle with HP same. So this problem, this is the simple problem. Here line is inclined to one plane and parallel to other plane. Right? Here line is inclined to HP. This is our HP. The line is inclined to HP and parallel to VP. This length is 70 mm. What about this length? What about the projection? This is A dash B dash. This is front view. What about the length of this projection? Because the line is parallel to VP, this must be 70 mm. That is, this is true length. Can we draw this line? Of course, we can draw this line. This is our XY. This is after rotating horizontal plane. This will become XY. Can you spot A dash? Yes, A dash is 20 mm above HP and 50 mm in front of VP. This is 20 mm. This is A dash. And what about A? A is 15 mm below XY line. This is A. Okay. What about? We know the true length. What about this angle? What about this angle? We have to draw the true length here, but we don't know this angle. How to draw this true length? How to draw this front view A dash B dash? Okay. How to draw? We don't know the angle. But here we know the distance of this point B dash from XY line. What is the distance of the B dash from XY line? This is 50 mm. We kept this distance same as the previous question. So we know the distance of B1 from XY line. What is the distance? This is 50 mm. So you have to take a distance 50 mm from XY line, right? 50 mm from XY line. And what about the distance of the line? That is true length. That is 70 mm. You have to cut an arc. Suppose you have to take a distance 70 mm. This is our 70 mm. Right? We got the front view. This is our 70 mm. This is B dash. Okay. Then drop a perpendicular. This is our projection line. What about the front view AB? It will be at a distance 15 mm. This is 15, right? It will be at a distance 15 mm below XY line. This is our XY line. After rotating plane method, this will go downwards. So this is our front view AB. Okay. We got our front view and top view. Front view and top view. This is not the original question. This is the front view and top view of the problem. when we make the line parallel to VP. Okay. In the original problem, we get a reduced length in front view and top view. Okay. So here in the second problem, not the second problem, after making the line parallel to VP, we get a reduced length. We get the top view right here. We get a top view. From this figure, we can measure the top view. This top view will be equal to the top view of the original problem. Why is that? Here this length here, see this length will be equal to top view of the original problem. It's because we are not changing the angle, right? We are not changing this angle, like, because the distance of the A from HP and distance of the B from HP is kept constant in the second problem. So we are not changing the angle with HP. So our reduced length, this reduced length will be same as in the previous original problem. Okay, but it is here, it is not parallel to VP. Here the reduced length is parallel to VP. The position is different, but the length is same as that of the original problem. Got it? So here we kept our angle with HP constant and we rotate our point B. We rotate our line B and made the line parallel to VP. In the second phase of the problem, we have to rotate the line again and make the line parallel to HP, keeping the angle with VP constant. So here in the second phase of this question, this is our line AB. Okay, this is VP, this is HP, this is our, can you see this? Okay, this is our first problem. Here this is, the line is making an angle with VP and also making an angle with HP. In the second problem, I am keeping the point A constant, that is this line is 20, this is 15 mm in front of VP, this is 15, this is 20 and this is 15. Okay, this is the point A. This is, and I am rotating the line keeping one point constant. I am rotating the line so that the angle with the VP, that is this angle with the VP remains constant. That means the distance of the point A from HP is 20 and here the distance also 20. At first case, in the original problem the distance is 50. I reduced the distance 50 to 20 so that the line is parallel to HP, parallel to horizontal plane. You have to keep in mind that I am not changing the angle with VP. That means I am not changing the distance of A and B from VP. This is 15 mm. Previously it's 15 mm. Here the distance is also 60 mm. Okay, from here to here this is 60. The first case it's also 60. This is 15 mm. Here it's also 15 mm. So I change the line so that it's now parallel to HP and inclined to VP. Okay, what about the top view? The top view, this is 70 mm. Length of the line is 70 mm. The top view you will get a projection. What about the length of the projection? The length of the projection is true length. It will be exactly 70 mm because the line is parallel to HP. Okay, what about the top view, front view? So you will get a front view A dash B dash here. Our top view is AB. We already got the top view AB, that is 70 mm. What about the top view? We don't know the length of the top view, front view, not top view, front view, because the line AB is inclined at an angle with VP. That means the line is inclined at an angle with VP and the projection front view must be a reduced length, that is less than 70 mm. We don't know the length, but we know the length will be less than 70 mm. Okay, so let's try to draw the projection. This is XY. After rotating horizontal plane, it will be like, can you see this? Okay, this is XY we can spot this is a dash. A dash will be 20 mm. A dash will be 20 mm above HP. And what about A? A is 15 mm below XY line. And what about true length? True length will be 70 mm. So there will be a top view of 70 mm. We don't know the angle. We don't know this angle, right? We don't know the angle, but we know one thing. We know that. But what is that? The point B. The point B is, what about this distance? This distance. This is 60 mm. So this will be 60 mm. So we have to measure 60 mm from XY line. We know the point B will be at a distance 60 mm from XY line. The point B is somewhere in this line. That is 60 mm from XY line. We know the length of the line. What is the length of the line? This top view will be true length. Length of the line is 70 mm. The line is parallel to HP. So the front view, not the front view, top view. When we are looking from the top, this distance will be same as that of the original length. That is true length. So distance of the front view, top view is 70 mm. So you have to mark 70 mm. You have to cut an arc. It will find out the point where it's crossed the line. That is 60 mm. So this is your line, position of the top view. This is B, position of the top view. So you have to draw a projection line, because this is your projection line. The point, we already find out the point. Okay, we find out the front view, not the front view, top view. We got the top view as a true length. We know how to find out this top view, true length. And what about the front view? Front view, this is front view. Front view will be in reduced length. Why is that? Because the line AB, which is making an angle with VP. If the line is making an angle with the projection plane, the image or the projection at that projection plane will be in reduced length, because it's making an angle. If the line is parallel to VP, you will get a true length, that is 70 mm in the VP. But here the line is making an angle. How can you say that the line is making an angle? Because see this point A and B, the point A is 15 mm in front of VP. Here the B is 60 mm in front of VP. If the line is parallel to VP, this length must be same, right? This must be 15 or this must be 16. Clearly this here the line is making an angle with VP. So in front view, from when you are looking from this side, you will get a reduced length. We find out the length and position of the line here. Okay, so we draw a projection line. This is our projection line here. This is our projection line. So we know that front view will be in between the projection line. Okay, in between the projection line, we got the projection line, and we know the distance of A dash from XY line. This is 20, and it will be a parallel line. It is the parallel line, parallel with respect to XY line. So this is our front view. So we got the front view and we got the top view. Okay, comparing with the original problem here, you have to listen carefully. Comparing with the original problem, by rotating the line, first we made the line parallel to here. First we made the line parallel to VP, keeping the inclination with the HP constant. We got a front view and top view. Again, next we made the line parallel to HP, keeping the inclination with VP constant, and we got a front view and top view. Okay, then what about the length of the front view? Here, what about the length of the front view? This length of the front view, this will be reduced length. We don't know the length. We can now measure the length. This is less than 70. Now we can measure the length. This reduced length must be equal to this reduced length, right? This front view is equal to this front view. Why is that? Because comparing these two image, this angle, we are not changing this angle, right? This angle, inclination with VP is similar in this picture and this also in this second picture. So the reduced length, I am not talking about the position, I am talking about the length. This reduced length is equal to this reduced length. So we got reduced length, that is we got the front view of original line, right? We got the length of the front view, not the position, length. So here comparing with the first figure, here the front top view, what about this top view? The length of the top view is similar to that of the original problem. Why is that? Because here in this problem we are not changing the angle with HP. We make the line parallel to VP, but we are not changing the angle with HP. So that reduced length will be same. So we got the length of our original top view. Okay, original top view reduced length. Okay, this is our original problem where the line AB of 70 mm making an angle with HP and also making an angle with VP. So in the front view and top view we will get reduced length. We don't know the reduced length and we don't know the inclination with HP and also with the VP. That is, we don't know the inclination with reference planes and we don't know the reduced length. So we know how to find out the reduced length in the front view and in the top view. The method is called rotating line method. Okay, first we rotate the line, making the line parallel to VP. Then we find out the front view and top view. And then after that we have to rotate the line, rotate the line so that it will be parallel to HP, keeping the inclination with VP constant. Then we have to draw the front view and top view. So that is the procedure. First we have to draw the XY line. So keeping the question aside, so this is our XY line. This is our XY line. First you have to fix one point common. One point, you have to fix the one point. So I am fixing the point A, you know. So you have to first draw the point A. The point A, which is the point A is 20 mm above XY line, 20 mm above HP. That is, so this is 20 mm. This is 20 mm. This is our A dash. And what about this length below XY line? Because the point A is 15 mm in front of VP, so it will be 15 mm below XY line. This is A. So this is our original question. First we have to make the line parallel to VP like this, and we have to draw the front view and top view. Okay, like this. We have to make the line parallel to VP, then keeping the angle with HP remain constant. So we will get a true length in the front view. So we have to draw a true length, but we don't know the angle. We don't know this angle, but we know the distance of the point B. This distance from XY line. What will be the distance of the B dash from XY line here? This is the same distance, 50. We as the original problem, we keep this distance because we never change this angle. Okay, we keep this distance constant. So you have to, here in this question, you have to find out that this point, this line, that is, this is 15 mm. Okay, this is 15. Draw the line 15 mm above XY line, and we know the length of the line, that is 70 mm. You have to cut an arc. Just suppose this is R70. So this will be your line B dash, right? So you have to draw the projection line. You have to draw the projection line. And what about this front view? This is 15. This is parallel to XY line. See, this line is parallel to XY line because this line is parallel to VP. So front view, top view will be parallel to XY line. So just draw here. Just draw a parallel line, and this is your B. Okay. This is your B. This length AB will be equal to this original reduced length. Okay, but this is parallel here. this reduced length is making an angle. Okay, then the next step is rotate the line here. Rotate the line keeping the angle with VP constant. Okay, keeping the angle with VP constant. So we will get a true length in the top view like this. Okay, and a front view, reduced front view like this here. Okay, so in the same question here, in the same question, consider the same question here. Okay, is it okay? Right. Okay, comparing the same question, now we rotate the line A. So here this is B2, that is, this is the top view true length when the line is parallel to HP, and this A dash B2 dash is the front view of this case, second case, not the second case, when the line is parallel to HP and inclined with VP. Okay, so we got two reduced length. This is the reduced length when the line is parallel to HP and inclined to VP, and this is the reduced length AB. This is the reduced length when the line is parallel to VP, and inclined to HP, the first case. So comparing with the original figure, this is our original figure. This reduced length, this is the top front view. This front view is equal to this reduced length, and this top view is equal to top view of the original question. Okay, we got the length, but not the position. Okay, we got the length. So what about the position? So we know in the original case here, by comparing with the original case, the reduced length will be at a distance. What about the distance from here to here? From here to here it will be 50 mm. That means the end point, this line B2 dash in the original case will be, the end point will be in this line, that is 50 mm above XY line, right? Here this is our XY line. The original front view will be 50 mm above XY line. So you have to transfer this point, you have to measure the line, this length, or you have to transfer, just draw an arc. That is, we are just cut an arc. You got this point. So this point, this is B1, this is B1 dash. This is your length and position of the original front view. What about the original top view? We got the length of the top view, reduced length. We don't know the position, we don't know the angle, but we know one thing. What is the length, distance of the point B from XY line? This is 60, so that is 60 mm. So you have to transfer this length to this 60 mm line. Okay, this is your B1, that is, this is your original reduced length. This is your original reduced length. So finally this point and this point must be in a straight line. So if you draw a straight line, it will be both the point. This is your original front view and this is your original top view. Okay, this is your original reduced length, this is your original reduced length, this is your original reduced length of top view. Okay, this method is called rotating line method. First you have to make the line parallel to VP and keeping the angle with HP constant. So first you have to draw A, and A 15 mm in front of VP and 20 mm above HP. That means in the first quadrant 15 mm in front of VP. This is A and 20 mm above HP, right? This 20 mm above HP, 20 mm above HP. This is A dash. This is A dash, this is A. And next we have to rotate the line. What about the point B, which is 60 mm in front of VP and 50 mm above HP, which is 50 mm above HP. okay, 50 mm above HP, 50 mm above HP. Just mark a line here, just mark a line here. This is your location point, and this is 50 mm. What about this length? This is 50 mm. This is 50 mm. 50 mm above HP. This is 50 mm, and 60 mm in front of VP. So you have to, again here you have to, this is the location, 16 mm in front of VP, that is below XY line. This is the location line. Okay, this is 60 mm. This is 60 mm. This is 60 mm. First you have to make the line parallel to VP, like here. You have to make the line parallel to VP and keeping the inclination with HP constant. So what you have to draw the front view. So what about the front view? We already got the position of A here. This is the position of A, and we know the position of B. B will be at a length 50 mm. Here see, the B will be at a length above XY line, 50 mm above XY line, but we don't know the position of B, but we know the length. This will be the true length 70 mm. So you have to take 70 in a compass. You have to take 70 in a compass. Okay, this is 70, and you have to mark the point. This is our A dash. Okay, this will be here. You have to extend the line. Sorry, here also you have to extend the 60 mm. Okay, this is your A dash. This is 20 mm above XY line, right? This is A dash 20 mm. Okay, this is your A dash. This is your B dash. This is your B dash. Okay, then this is the front view and top view. Top view will be, this is projection line. Top view will be parallel to XY line. See here, this is the front view and top view. Top view is parallel to XY line because it is parallel to VP at a distance of 15 mm. Parallel to XY line. This is your B, A, B. Okay, so next you have to make the line parallel to HP. You have to make the line parallel to HP and making an angle, keeping the angle with VP constant. So you will get a true length in the top view, right? 70 on the top view. What about the distance from here to here? That is constant, 60. We know the distance, that is 60. So again, this is our 70. You have to draw you have to draw 70 here. This is our line. This is our top view. Top view when the line is parallel to HP and inclined to with VP. So this is our line, and this is B2. This is B2, and you have to draw the front view. Front view, you have to draw the projection line, that is front view here. What is the front view? Front view will be a straight line in the reduced length. It will be parallel to XY line because it is parallel to HP. This distance is equal to this, that is, this is 20 mm. This is parallel to HP. Front view will be a straight line but reduced length, which is parallel to XY line, like this. Okay, here. So here it will be here, right? The distance 20 mm above XY line. This is your B2. We got both the reduced length in this original problem. Here in this original problem, it is the reduced length, front view is reduced length, top view reduced length. So here we got the reduced length, but in different position. So the position is, how to get the original front view? You have to just measure, you have to measure this length and you have to transfer this length to this line, and here also you have to measure the reduced length. This is your reduced length. Okay, you have to transfer this reduced length into this line. Okay, why is that? Because the original line, original reduced length is at a distance 60 mm above 50 mm above xy line. This is the 50 mm line, this is above xy line. So this is our original front view, and this is our, we have to transfer this line here. This is our original top view, which is 60 mm, which is original top view, which is 60 mm. Here to here the distance, here to here, this is here to here, the distance is 60, here to here 60, so here to here the same distance. So this is our original top view. So this is B1 and this is B1 dash. When you draw a line, the both the point will be in a straight line. Why? Because the front view, this is the front view and this is the top view. This will be in the straight line, right? This is the front view, this is the top view. It will be in the straight line. So you have to darken this line. This is the original position of the line. Okay? That means when the line is inclined at both the plane, when you look at in the front view, that is in the front view, you will see the line in a reduced length. This will be the length of the line in the front view, and it will be the length of the line in the top view, not 70 mm, it is less than 70 mm. And in the next part of the question, it's asking us to find the inclination of the line with both the reference planes. What is the inclination of the line with reference plane? That means HP and VP. See, listen carefully. This is the angle. Okay, suppose this is the angle theta. Suppose this line makes an angle theta with HP, theta with HP and phi with VP. Okay, suppose some angle, it makes an angle theta with HP and phi with VP. When you draw the, when you look from the front, the angle, you cannot see the angle theta. Got it? When you look from the front view, you saw the line making an angle that is not the exact angle, because the line is inclined to both the plane. So as an optical illusion, you cannot see the angle. The angle will be greater than the original angle. So how to find out the original angle? So here you have to measure this angle. This is your theta. That is, measure the angle of true length in the front view, that will be the theta, and measure the angle of true length in the top view, this will be the angle phi. This is the original inclined angle with HP. So when you saw in the front view, you felt like this line making an angle, this is alpha. I think this is the alpha. You saw the angle greater than theta, that is alpha, but that is not the original angle. Theta is the original angle, and this is beta. When you look from the top, you feel like the angle, the line is making an angle beta with VP, but actually the original angle is phi, which is less than beta. Okay, I think I am clear. Bye.